think maybe it's, you know, I don't want to spend too much time going over what we did yesterday, but yeah, so let's start with we're going to do a couple very simple things in a new notebook. So just make sure you have a new notebook. I'll call this day 2, session 1. Yeah, okay. So again, like what we have here is this is just a file. Like I'm just working on this file. It's in this directory. There's another subdirectory in here called data. I can access it just like I would in my file finder, right? Like it's like I'm working within this folder structure. To begin, what we're going to do almost all the time in a Jupyter notebook is import the libraries that we're going to be using. So today we'll be using a couple different libraries. To start, we'll be focusing on pandas, but we'll just go ahead and kind of get used to the typical library loading that happens in most notebooks. Like, at least for me, the libraries that I use a lot are going to be the plotting library, the numerical library, NumPy, pandas, the data frame library, and sometimes I use Seaborn, another library for plotting. Now, if you have Anaconda, you have all of these libraries kind of built in with the package. That's one of the big reasons for using Anaconda, is that you don't have to then install all of these libraries like David mentioned. So there are standard ways of importing these libraries, or standard names for the abbreviations that you'll see like from consistently wherever you look, like importing pandas as PD, importing matplotlib pyplot as PLT. So like what I'm introducing here is just like what I'm familiar with everybody kind of using with these libraries. The last thing that we're going to see is we're going to see first this thing called a magic function, because it's kind of magical. Like it's really magical. It makes the plots appear within the notebook itself. Okay. There's a lot of different magic functions, and you can get into them, but we'll just be looking at this one, which allows us to produce plots within the notebook itself. If we didn't put this magic function, then the plots that we would make would pop out as a separate screen, okay? And you could save it as an image and so on. But we're going to make it a continuous document. So we'll start with that. Magic functions begin with a %. So it's %. Make this a little bigger. And I'm going to type matplotlib space, and I'm going to type notebook. Now what this does is, again, matplotlib is a plotting library, a Python plotting library, and we'll be using this to generate some plots today. This line tells the Jupyter notebook, hey, when I make a plot using matplotlib, put it in the notebook. Okay? There are other options that you might see. You may see notebooks that say matplotlib inline. That does the same thing. It's just a little, the notebook is a little bit newer functionality with some kind of nicer features for the plots than the older inline. Okay? So now we've told our notebook that we're going to produce the plots in it. I want to also import the plotting library. So this is a little bit verbose, but it's import matplotlib dot pyplot space as space PLT.
In the beginning, you just want to also show like the from import ones, so people know like both of those. Like from matplotlib import pyplot as PLT. It's like less efficient, but just.
So there are like you know, within matplotlib, like there's pyplot is a part of matplotlib, so I could say from this larger library import this other thing. Okay, that's another way I could do this. Like there's a math library that has some math functions like cosine, something like this. So we could also, you may also see something like from math import cos. Okay, so then what this does is this tells the notebook, hey, sometimes I'm going to be calling this thing cos. When I do, go in that math book and look at what it tells you to do. All right, that this is just calling one of those. Like I'm saying, just import a part of a library rather than the entire kind of thing, right? You may also see like from math import star, and that means import everything. I don't tend to do that. I mean, I can't claim to be an expert, but if you do this, there are times where if you have multiple libraries, things may clash. And so you don't want to just kind of be referring to functions. In this example, if I import matplotlib pyplot as PLT, then when I go to use something from this library, I'm going to preface it with PLT. Otherwise, I won't. If I go to use something from math, I'll just type the function itself. I won't preface it with anything. And it could be that these two things have the same function. Like maybe I import, there are things like NumPy and in the math library have the same functions. Like I can do cosine from NumPy, or I could do cosine from the math library. If I have imported both of them like this, then when I call cosine, well, what cosine? From which library? You know? So it's just my understanding that it's better practice to have these prefaces and not to import a library en masse most of the time. How do you feel about that, David?
100% agree with you. And like one example is in machine learning, sklearn, which I wrote on the board yesterday, is huge. There's so many packages, it takes up so much processing power. If you just import sklearn, it's going to slow things down. So you might import the metrics package or the linear regression package. So it's a great habit. And the best one's really line 2, what Jacob wrote, like import matplotlib.pyplot as PLT. Like that's the best one, if you could.
Yeah, right, there are very large libraries that you don't want to necessarily kind of occupy the entire space. Yeah, for sure. Yeah. So again, like I don't. I have a couple of there are a couple of libraries that I'm just using all the time, and there are a couple that we'll use today. First is this plotting library. Also, we're going to import pandas as PD. And I'm going to import, I'm just going to import NumPy as NP. And this is usually how I start almost every notebook that I use. Like these libraries do most of the things that I'm going to do. You know, like David said, if there's some machine learning happening, maybe I'll use sklearn or something. If I'm doing some statistics, maybe I'll use stats models. But usually these are kind of the go-to libraries for me, and they're things that we'll use today, maybe with the exception of NumPy. So after that, just execute that cell. And as long as you see your number appear, then you have those libraries loaded and ready to use. Okay? So the first thing that we'll do is we will read some data into our notebook. Again, that we should have all the gapminder data in a data folder here.
I think I had them download different data, or you this morning.
Yeah. So you should have a number of different gapminder data files. We're going to load in the Oceania one. Okay? So I'm going to load in this file, and I'm going to create a data frame with it named data. Okay, so I'm going to create a variable, data, and I do that by typing data equals. And it's going to equal me having read in this CSV file with pandas read CSV function. Okay, so to use the read CSV function, I type PD because it's a pandas function, dot, read, underscore, and if you hit tab, well, usually if I hit tab, it should show me my other options here. Like what kind of options? Yeah, it's just because I have my screen kind of zoomed here. But this is a very nice function of the notebook, is the tab complete, all right? And you can see all the different ways that you can read information into pandas, right? You see that there's even a clipboard. This is nice if you copied like a table from a website or something. CSVs, there is an Excel, you know, it's all on HTML, JSON, that was what we saw, that the OpenRefine file, the script was a JSON file. And the notebooks, these notebooks themselves are JSONs. So we want the CSV. And in parentheses, quotation mark, now I just have to enter the path to this file. So because I've kept, because I have this file structure, because every time I start my data files in this subfolder called data, then I can just type data / and if I type tab there, I also can see the different data files to choose from. So we should have our different Gapminder data files here ready to be selected, okay? So I want the Oceania one. Okay, that's a good, and this may be an opportunity to kind of double check yourself that you have the data in the right place and that you've downloaded it.
Can it be referenced on our desktop or it needs to be separate?
No, you can put a full file path in there, yeah. This is like, I mean, okay, so if I, say that again?
I need to type desktop first, not data.
Well, it depends. What does your, if you, again, like, here's what my folder, I have a folder on my desktop called, well, I guess I'm in a folder called Python right now. Within that folder, I have another folder called data, and I have my notebook file. So if you're working in a notebook that also has in that directory a folder called data, then you should be able to see these files.
And if it's not in a subfolder, I'd have to call the specific file.
You can give the whole file path, yeah.
Okay.
But I would say try to avoid doing that, you know, yeah, try to get it set up so it's easy to kind of navigate to your files.
Okay.
Can you go back to that input?
Yeah. Just in terms of navigability, like you're not gonna. If I'm doing a project, then I want to have my data there. I don't want to have my data files in a different projects folder. So like, I mean, you don't have to do it this way, but do it this way. You know what I mean? Like this is, I promise you, I didn't used to be as organized and deliberate with where I kept files and things like that. It's better to be that way, you know? It's better to clean your room, you know?
Yeah, and this is what I was kind of telling you guys yesterday, like creating a data carpentry folder and then in it doing a workshop and like just very structured.
Yeah.
So which file do I need to clean?
So you want Europa. We're gonna look, or I'm sorry, Oceania. Sorry.
Yeah.
If you were able to load this in as a variable called data, then you won't have an error, right? Should just go through. And we can take a look at this now. However, I think this is a larger data frame. You know, this is a little bit larger file. So we can get some information about it by, first I'm going to type data.head in parentheses. We saw this yesterday, right? So that just shows me the first 5 rows. However, there's not even 5 rows in this. How come? Yeah, well, so the head command, the default is going to be 5, right? But there's not 5 rows here. How come? There's only 2 countries in this place called Oceania, yeah. Right? It's just Australia and New Zealand. So if we look at it, if we had a different data frame, this would show us the first 5 entries within that data frame. Okay. We can also get information about the data by using .info. So for example, data.info. So we've read in the CSV file. We've called it this. We've named it data. We've looked at the top of it, and we can get some information about it using the info command. Right? What is it? What does the info command tell you?
The column names,
How many columns?
how many entries.
Yeah, and the different kinds of things for each of those, right? The country, right, is a non-null object. What does that mean? Why is that an object?
Like a name.
Yeah, it's a name, right? It's a category. Whereas these other ones, the GDP per capita 1952, is a float, 64, right? The decimal number, right? Yeah. So it tells you what kind of variables you have for your different columns. And that's good because maybe somebody gave me a CSV and there's a problem with some of the data. So by doing info, that would show me maybe there's an object, because if one of these, if 1972, maybe for Australia had a B, like that was that was what somebody had entered for it. Well, then that whole column would come back as an object instead of a number, and I could see that here. All right. If I have columns that I expect to be numeric and they're not, well, I can uncover that quickly with the info command. Okay, the head doesn't. The head shows me what I have here, but it doesn't tell me about the data types.
So when you go to.
Okay, we can also, if I want just the column names, I think we saw this yesterday, I can just do data.columns.
Save it underneath the same place.
Sorry. I don't call that. Yeah, no parentheses with the columns. Just dot columns. So, you know, what kind of thing does this look like? Do you remember this kind of thing? It's a variable, and what did it, like it spit back this,
It's like our definitions.
like a dictionary?
Yeah.
Oh, okay. Yeah, I think that we can call, like, certain parts of it, pieces of it, right? Like if we wanted one of these entries or something, we could then reference it from this thing, right? Like, so, does anybody remember how I might do that? Data columns. Like, what if I want GDP per capita 1957? 2? So that column, you know, that column command, what it did is it returned us a certain kind of thing. One of these list things. And I can act on that just like we were acting on those lists that we were creating yesterday. You know, where I'm asking for the index 2, right? Why does 2 give me 1957? Well, because it's the third thing, right? 0, 1, 2. GDP per cap 1957, right? I think we can select a range of these values as well. So maybe I just want, you know, the 50s and the 60s. Maybe I just want those columns, right? Then I can refer to that by saying data.columns, and let's see, I'll do 1 to 4. So 1:4, and let's see if this gives us what we wanted. Is that everything I wanted?
No.
No. What am I missing?
You would have to do it as like 0 to 4.
It is missing
To get all
1967.
The last one.
Yeah. So the 67, right? But what should that be? This is 0, right?
Yeah.
1, 2, 3, 4. So, but I put 4. So what does that tell you about how the behavior of this kind of index slicing works?
It doesn't include the last number.
Yeah, it doesn't include the last number, exactly, right? So if I put 5, then I'll pick it up, right? But that's important to recognize, is that if I'm doing this by kind of location here, we'll see it again in just a minute, but it doesn't include that last piece. Like 1 to 4, it's 1 to 4 without 4.
So that's gonna count 2, 3. 2, 1, 2, 3.
This counts 1. This will show you
The fourth.
1, 2, 3, and 4.
Okay.
Not
Yeah.
5. Yeah, it's like start at 1 and stop before 5.
Why the data type is object here?
Good question. Yeah, because these are objects, right? Like the column is a column name, right? So it's just a title. So it's just saying that column name is this list of things is a list of object types. Yeah, great question. Okay, one other thing that we can do here is we can get a quick look at kind of some summary statistics within the data frame by doing the describe command. So if I do data.describe, yeah, it summarizes each of those columns, right? It's kind of like the 5, I don't know if you all remember 5 number summaries. These are really kind of helpful ways to understand your data, and it includes counts and standard deviations as well, right? But think of it as like I mean, this is basically a box plot, right? It's without the boxes. It's just the things that would be a box plot. It tells you your mean, standard deviation, and your quartiles, right? And minimum and maximums. So nice, easy, kind of quick description of the data. You know, if you wanted to know something like, yeah, when was the largest GDP per capita, what year had the largest, or something like that. Quick, easy way to find it. You can also use the max function. Okay, so why don't you go ahead and try to load in a different file, maybe the European file, and repeat these operations. Load the CSV in. Look at the top 5 rows, look at what the column types and the information about the column types are, get a summary description of the data, and maybe look at just even the column names to begin.
Right, only if it's been entered once already. This is your first time entering it.
You know, I mean, I think that you might want to be trying to keep notes in your notebooks. So just remember, we have these Markdown cells that allow us to do that. I think that yesterday we were changing from the toolbar to change these to Markdown cells. There's also a keyboard shortcut. It's kind of odd, but if I'm in this cell and I want to change it to a Markdown cell, I can do Control M and then hit M again, and it's a Markdown cell. And I can write notes in it.
Okay.
So to make a list, because there's a couple of kind of important things that we just discussed here in terms of functions. So to make a list, like I can either number it or I can just use these dashes and space, and that'll make a bulleted list. That's Markdown. And yeah, so what we were using here, let's see. So I'm going to use a backtick and do data.info backtick. All right, and this gives information about data frame. Do another dash. I'll do backtick. And I'll say data.columns. Shows column names.
Jacob, if you have to do Markdown, so we could
I wonder if
just
that's
directly
what
go
it says, like the tab.
there and do the Markdown.
Say that again?
Markdown. So, control L.
Let's see, what else did we just see? We saw data.head. Shows first rows. Backtick data.tail. Shows last rows. And one more data.describe. Shows summary stats. So I'm just kind of doing this so you can get a little bit of an understanding for how to use the Markdown and also to integrate a little bit additional kind of syntax there. These backticks, what they're going to do is they're going to render it a little bit differently, like code. All right, so we see a little bit of Markdown here, both a list and how to write like a coding command. Okay, there's even more where I can get it to make it be like Python or R or whatever language, but this is good. So if you execute this and you have your, you know, like you can tell that this is the command and then this is my description about it. Okay, nice way to keep some notes. And this is what we were just talking about. Okay? Yeah.
I think data info with Brent.
Oh no, yeah.
It shows different things. They both work. Right? I just did accidentally.
It outputs it differently, right? Yeah, like if I do data.info versus data.info here, yeah. Displays the output differently, right? And it gives me the actual values. Why? Yeah, I don't know. Help me, David. If like, why am I seeing two different things if I include the parentheses? Like, it's displaying it as a. Both of them are saying they're data frames. This is only giving
Is the
me.
columns because you requested things to appear columnar, if not data versus that. We should check the package. Right?
Yeah.
See if, it looks like .info. Maybe one of them is default Python and one is a pandas. You know what? That one's pandas and the other one's not pandas. So .info is default Python and .info parentheses is a pandas data frame. So it's a pandas function. Okay, so what that means, just for you guys for clarity, so Python by default has functions like we worked with yesterday. So the first .info without parentheses is a method, or call it procedure, built into Python, and the one with the parentheses is actually from pandas, but certain pandas methods don't require doing pd dot. You can just do dot after, and so that's what we're seeing as a distinction.
Yeah. That's good. Very good. Yeah. There's. What are some other ones that we might like kind of run into?
Guess we'll run
I don't
into
know.
them when
Well,
go
maybe
into-
we'll run into them. Yeah. Yeah. Okay. So. Yeah. So here we go. We've got a few commands to kind of dig in, load our data, understand it a little bit. Great. Okay. We good? Keep going. All right, so the next thing that we want to do is we want to look at how do we find some things, like how do we dig into the data and slice and dice it up into smaller pieces a little bit. The first command that we're going to look at locates based on an index. So remember that I have my, I'm going to read in my European data because I think I asked you guys to do that and I haven't done that yet. So I'm going to say Europe. I'm going to call this variable Europe now instead because that's a little bit more appropriate name for it. Equals pd.read _ CSV. And then I know that I have I know that I have this in my data folder, so I'm going to do data / just tab and look.
Europe.
Here it is, Europe. Okay, and if I want to, I can say Europe .head, and I'll put 10 in there, and we'll see the top 10 rows of our new data frame. Okay. So here's our data. It has the same information as the other data frame did, right? The GDP for these different years. It's just that it's got more countries. Okay. If we want summary statistics for this, we could use describe and so on. But maybe I just want a smaller part of this, right? Like maybe I just want to know about a specific country in a specific year, in a particular year, right? So I can do this with a function called iloc. So if I say Europe .iloc, what I'm doing is I'm going to say, okay, I'm telling you. Let me get an error here. Sorry, I just wanted to make sure you can see this. What this means is an index locator. Okay, so that's what it's a little bit cryptic, the iloc, but it's index locators. Okay, so by index locating, what does that mean? Like if I'm gonna find something based on its index, what is that?
Variable index kind of variable, and then
Yeah, so like here, let's say names equals Jacob and Hennessy. That's my dog, right? Like, if I want to refer to these, I could refer to one of them as like the actual entry. I could say, oh, this is Jacob. But I could also refer to it by its index location. Like, where is this thing, right? So where is my name as an index? Like, what does that mean? What's the index of my name here? This kind of thing. 0. Yeah, exactly. Right. So I could say, oh, go find this thing, and reference it by the thing itself, like say Jacob, or I could be even lazier and say just go find this thing that's in the 0th position. Okay, and that's locating it by its index. So that's what the iloc is doing. So let's go ahead and pull out Albania's GDP per capita in 1952. Okay, so what's the location of that guy?
country.
Yeah, and so what's the index of that country, right? 0. And what about if I want that GDP per capita? Like, what would the index of that be?
You'd have to put in the, which year are we looking at?
1952.
52, so 3,
1.
2.
Oh yeah. It's like
It works like a chart, right?
it does, but remember the funny indexing with Python, right? It starts at 0. And what is the 0th here? Like if we can just try 0, 0, right?
Country column.
And what does this
Yeah.
give me?
Albania. So the country column is 0. So 52 would be 1.
So 0, 1.
Yeah.
Okay.
Yeah.
And again, like this is, it's kind of, if you, it's always kind of backwards, right? We start the enumeration up in this left-hand corner, and that's not always like where, in like math class or something, we might see it different. But what this does is it goes into the first row, the second column, and pulls that value. So when would you want to use this? When would you not? Well, you have to know where the thing is, or you have to kind of trying to be interested in finding what the value of a thing in a specific location is. Like you need to know where you're going.
If you don't know, what?
Yeah, what if you don't know? Right, exactly, right? So maybe instead, like I just wanted to find, instead of by the index, I wanted to find Albania, right? Instead of, and I don't know where it is, but I know it's in there. Well, I can also find things by just locations of the actual name itself with the lock function, okay? So if I do Europe.lock, and now I'll say Albania, in parentheses, comma, GDP per cap underscore 1952, I got an error. And it says here Albania is not in the index. So this is good that it's good when I make mistakes. You know, at least this one, because I know what the mistake is. It's good when I make mistakes and I know how to solve them, at least. So
Does it matter if it says lock versus iLock?
it does. There's a difference, right? Like in iLock, what we're doing is we're referring to it by its index, so we would give it a number. Here, by lock, what I'm doing is I'm referring to it by its name. So I put the names in, but it says, oh, but it's not in the index. So if I look at my data, you notice that there is this column over here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on, right? This is the index column. Like it tells, this indexes our rows for us. Now, the reason that it didn't work for me is, yeah, because Albania is not the index column, right? Here's the index for this. However, I can create the index column based on country if I want. And I'll do this when I read the data in. So if we navigate back to our read CSV call here, and we just add to it and say index col equals. Okay, so again, I'm just back here where I read in my Europe CSV folder or file, and I'm going to add this argument here that the index underscore col equals, and I'm going to make the index column the country column. So I'll have to tell it the name of that column. All right. So I'm going to tell it parentheses country. And now if I execute that and look at the first 10 rows of it, it looks different, right? I no longer have the numbers as the indices here. Instead, I've indexed this entire data frame using those countries. And I'm going to keep my fingers crossed that, well, first off, this will give me this should give me a different value now. My iLoc, and also I get the actual value when I look for the GDP per capita using the locate now. Okay. Why did this change?
Can you scroll a little bit further?
Yeah.
So now, thank you. Okay, so-
Yeah, let me, and I'll even make this just the 5 so you can see more.
That's-
So yeah, why did this change?
We just changed it.
And what did it change to? What is this value?
So there's something for index, is that 1957 or something?
Yeah, 1942, it's 1957, right? Because now, right, the column shifted over. So now that I'm calling this column 1957 as opposed to the 1952 when I had the just generic index in there and country was the first column.
So it does not count country as the zeroth index. It starts from 1952 as the zeroth index.
Well, it had imposed its own index. Like, you know, we don't get into the different. There's this idea of a series, and a series is like an indexed list, sort of, and that's really what Pandas kind of is doing. Is it's indexing these lists and creating this structure, right? We can force like an indexing on it. We can say instead of using this 0, 1, 2, 3, like use these names as the index or something. So that's what we did here. Okay. Great. All right. So we can get more than a single. We can get more than a single value out of these slices, though. So if I want to get all of the information about Albania, for example, I could do Europe.loc. I'm still going to type Albania. All right, that'll go and grab me Albania. But instead of putting a second value here, I can just put a colon, and what that does is that says take everything. Like, give me this row and all of the columns. And sure enough, right, there's all of our GDPs for Albania. What else do you think this allows us to do? This colon? Well, I could swap positions, right? I could swap the position of it. And instead, I could use the colon and then GDP per cap, 1952. What would that give me? All of the countries for that year, 1952, right? Go ahead and try that. Make sure. We can also apply methods to these. If I wanted to know what the mean of this was, what the mean GDP in Europe in 1952 was, then I can just type the same thing and say dot mean. And a lot of these methods are what you would expect, you know? Like if you wanted to find the maximum there, it's like max, min, standard deviation is STD, I believe, or DEV. I don't even remember them. Like I just Google it. You know, so but they're very straightforward, yeah. And honestly, the describe gives me all of that. So usually I'll use the describe on a certain thing. Like describe, right? So if I even want just a description of that column, like if I just want to know the descriptives for that year, 1952, then I could do this, right? Like I take all of the rows of that column and then apply the describe to it. It tells me, okay, there's 30 countries. The average GDP was 5661, standard deviation, minimum, maximum, in quartiles, right? Okay. There's other ways that we can select, like, you know, to this point what we've done is we've seen how do we select a row and some columns from it, how do we select a column and all the rows, but maybe what we want to do is even kind of zoom in a little bit more, just like select a few rows and a few columns of something. But we can do that as well by combining these two kind of ideas. So if we do Europe.loc, and now I'll go from Italy through Poland, and I'll do, let's say, GDP per cap underscore 1962. Yeah. Let's just get 1962 to 1972. So GDP per cap underscore 1972. And that just sliced like a smaller kind of part. It gave me the countries starting at Italy, right, ending at Poland, starting with the column GDP per capita in 1962 and ending with 1972, right? Again, this included these values. If I did an index locator, it wouldn't have. Like Poland wouldn't be included if I had referred to it by its index. GDP per cap 1972 wouldn't be included if I referred to it by its index. Okay. All right. We can also look at things that have certain values. Like if I wanted to find everything, every country that had a GDP larger than 10,000 during these years or something like that. I can do that with a Boolean expression. So first, yeah, let's say that we have this data frame, okay, or we have this subset of data from Italy to Poland and GDP per cap 62 to 72. And then what we want to do is we just want to find anything that has a value over 1,000, okay? So I'm just going to copy this and name it a variable subset. All right, so subset equals that same thing, that locator from Italy to Poland and 62 to 72. So now I have this thing called subset, all right? I could print it, so I can say print the subset of data is, I'm going to introduce this /n, and outside of it I'm going to put a comma and say subset. So let's execute that and think about what this did. This is I think that we saw some regular expressions yesterday, but yeah, like what does this /n do? New line, right? Okay. This is, and I have to use this kind of special character because otherwise it would interpret it like it's within where I'm saying there's text, you know. So if I want a new line, I just have to use this /n. Okay, you'll see this if you ever do some text processing or natural language processing and stuff, like regular expressions are good. But so here I have this thing, right, this subset of data called subset. And maybe I just, like I said, I want to know where things are bigger than 10,000. So I can actually print the same thing, just copy and paste that, except I'm going to add to this where subset is greater than 10,000. It didn't give us the values, right? Like it didn't go and actually get us those numbers.
Yes or no?
Yeah, it just said whether or not that is the case. Like, is this entry bigger than 10,000 or no? Right? So it just returned Boolean values, true or false, here. There's another way I could do this by using what's called a mask. And that will return a little bit of a different output. So let's create this, this limit by calling a new variable mask. So mask equals subset greater than 10,000. And then I'm going to apply this to that data, okay? So I'll say print subset and then brackets, I'm sorry, parentheses, no, brackets mask, yes, lost myself there. And what we do is we, instead of getting true false, we get the values back when they're true, and it says it gives us back a nan otherwise. The reason that this is better is because those nans will be ignored if I did some computation on it. So for example, if I wanted the mean values of 1952, but only the mean for the countries that had a GDP greater than 10,000, well, I could do this and then ask for the mean, and it would only apply that to those values that were selected here. It's not going to be problematic for the nans. Okay? Yeah?
Do you think it's better practice to define mask like separately, like you did as a variable, or to just put the subset greater than where you wrote mask?
I think it's better to have it as a variable because then you can reuse it. Like you can apply it to different slices of it, whereas if not, then you'll have to just be typing it in every time. That would be my kind of biggest reason for doing that. Yeah. If you had a long mask, you know, you could chain a couple of things. You could say greater than 10,000 and less than 20,000 or something. And if you have a bunch of these things, it's going to be a pain to write it every time maybe also. But yeah, like these masks, you can do all of these kind of, you know, greater than, less than, ins, like Boolean kind of operations. You can chain a bunch of them together and get really kind of specific entries if you have something specific you're looking for. Like, yeah. this data isn't like incredibly robust to do too much with like that. But if I wanted to know any country that's like started with an A that was had a GDP between 10,000 and 13,000 in a certain year, like that would be a little bit painful to type every time or something. I don't know. Yeah, it's not a good example. Sorry. Okay, so those are the subsets. Yeah, let's see. Okay, good. Yeah, this is a lot. So let's look at a different. I want to give you guys a chance to apply some of this to a different data frame. All right. Let's look at the gapminder all. All right. So if you, I can call this all equals. Actually, call it gapminder underscore all equals, because all is a Python function. Equals pd.read underscore CSV. It's in my data folder, /, and here it is, gapminder all. Gapminder all dot head. Okay, so what kind of data do we have here? You know, what's the information that we're presented with? It's a little bit different this time. What's different about it?
They have continent as well as country.
Yeah, we've got two kind of categorical pieces, right? We've got both the continent and the country, right? Where before we just had countries. So you should be able to kind of slice and dice these depending on maybe a specific country. Maybe you want to find a range of countries. Maybe you want to find something about a continent. Maybe you want to find all of these different years, like for countries that begin with B. You should be able to kind of think about how you can use these locator functions and masks to do some of these things, right? So why don't we just kind of try to ask 2 or 3 questions about this data set and use either the locators or the masks, the slicing and dicing that we've seen to this point to hone in on that information. Like maybe you can tell me what the average GDP in Africa in 1962 was. Maybe you can tell me what the average for Botswana's GDP was throughout all of these years. Maybe you can tell me all of the countries from Angola to Burkina Faso, like what their average GDP was. But just come up with 3 questions that you think you could ask about this data frame, and then use the slicing and dicing to surface that information. Okay? And give me a green sticky or a red sticky as you need.